Hello friends, in this video we are going to determine shear and moment functions. It is very important for drawing the shear and bending moment diagram. So we will start our next our new topic, that is shear and moment function. Let me start from simple example. Determine the shear and moment in the beam shown in the figure as a function of x. Let this is distance x from the support A. From the support A, this is distance x. I have to find shear and bending moment at distance x. That is shear and moment at distance x. I have to find this. For that, I will make a section here. I will consider this section A and I will take this as B. I will consider A and B section. And for that I have to first find support reactions at A, because then only I can find shear and bending moment at distance x from this support A. Let we start. So we have to first consider this whole structure. So I will consider here and I will draw free body diagram. Here will be three reactions because it's a fixed support. One is momentum, that is MA, and one will be vertical force, that is VA, and one will be horizontal force. There is not any horizontal force, so horizontal force will be 0. So if we do not write it, it is better, so I will not write it. And this this is a uniform varying load. I will draw a single point load instead of this uniform varying load. It will be at a distance of 30 into 30 by 3 from this point. So this is 10 feet. So this will be 10 feet from this end point, and it is magnitude will be equal to area of this triangle. So it is 1 by 2 base into altitude, that is 30, which comes out to be 30 pound. 30 into 2 by 2, that is 30. And this distance is 20 feet. This is point A. Now I can use this equation, summation of momentum at point A equals to 0. So I can write MA. This will try to rotate beam in upward direction because beam is in this side. So MA plus, due to this force it is passing through the point, so momentum will be 0 due to this force, and due to this force, sorry, it will be negative, minus 30 into distance is 20 feet, minus 30 into 20, and there is not any force or momentum here, so which is equal to 0. So I can write MA, momentum at A, will be equal to 600 pound feet. This is momentum at A. Now I have to find this vertical reaction VA. So for that I can write summation of vertical forces will be 0. So vertical forces VA, this is our positive direction and this is in opposite direction, so minus 30k equals to 0, which further implies our VA, which comes out to be 30k. So now I found these two support reactions. One is momentum and another is vertical force VA. Now I can find shear and momentum as a function of x easily. Let me take this section which is at a distance of x from the support A. I will take this section. So this is point A. Here are two support reactions. One is 30k. This is in above direction, and here momentum, which is 600 pound feet, and this distance is x. Let me take this as y, this force, and I will take this as y. And you know, this by similarity of two triangles you can write x, so this side x divided by 30 equals to y divided by 2, because this is the ratio of corresponding sides of similar triangles, which is equal to this ratio of corresponding sides of similar triangles is equal. So I write x by 30, y by equals to y by 2, so which further implies y equals to x by 15. So I can write here, I can write here x by 15 pound per feet. Now to find shear force and bending momentum at this point at a distance of x from support A, I have to draw free body diagram for this structure. So I can draw a free body diagram easily. This is point A, this is 30 k in above direction, in upward direction this is 600 k feet, and this will be at, from this point this will be at a distance x by 3. So this distance will be 2x by 3. There will be resultant force because of this triangle uniformly varying rod, and it will in this force will be, and this force will be 1 by 2 area of this triangle, that is 1 by 2 base is x into altitude is x by 15, so which is equal to x square by 30. So I can write x square by 30 pound. Now I can find easily this shear force and bending momentum at point this at point, if I take this as point C, it is at a distance of x. So I will use first equation, I will use summation of momentum at point A equals to 0. Sorry, here will be 3 forces because we are breaking this beam. One will be summation of momentum at point C, another will be this vertical force. I will take this direction, I will write this as C V. So I will write this as vertical force at C, and there is not any horizontal force, so horizontal force will be 0. So now I will write summation of momentum at point C equals to 0. Summation of momentum at point C equals to 0, which further implies summation of momentum at point C is due to this 30. It will be 30 into distance. This distance is x, minus this is 600, minus this is in downward direction, force is x by 30, and the distance is x by 3, and this is also in downward direction. This will also try to rotate beam in below direction, so this will be minus mc, which equals to 0. So I can write mc equals to 30 into 60 minus 30x minus this is x square by 90 minus 600. This will be momentum at point C as a function of x. Now we have to find this vertical reaction at point C. Now I have to find VC, support reaction at distance x from this support A, VC. So I can write summation of vertical forces equals to 0. Summation of vertical forces equals to 0. So I can write 30k plus VC minus x square by 30 equals to 0. So I can write VC equals to this x square by 30 minus 30k. So this is our support reaction VC as a function of x at a distance of x from the support A. If you put values, let me put x1 and 2 or 3, this VC will come out as negative. It means our assumed direction is this wrong, so we can change